even though it was a large group. Now, we talked about money cards, so I'm just going to look, okay. Here's an example of a money card. Remember we said that you stop 5 minutes before the end of class if you want to fill them out and you want to collect them, and you do have to provide some response. And in the Dropbox, there's a file called money cards, text file. Okay, so we talked about that. Oh, I guess I'm not going to talk about the others. That's why I jumped to 4. So that too. We talked about concept questions, and you have heard Mr. Concept Question, Eric Missouri. Okay. And cooperative learning, we talked about that, and we've done a lot of cooperative learning this week. So then I want to jump to, I guess I really want to talk about number 4. Case studies and simulations, especially if you have things like ethics in your course, and you're responsible for discussions on ethics, case studies and simulations, particularly case studies. You just have to, read your technical journals. What has gone on this week related to engineering? What's the current state of affairs? What are the ethical issues involved? And now, I suppose if you watch the news coming with Rupert Murdoch, I didn't even get the beginning of the story, so sometimes if I travel like this, so now the rest of my life there will be this gap in news, like I don't know what's going on in the world for 2 weeks, because I haven't read a newspaper. But actually I've read the newspaper, and I do know that there's been a Rupert Murdoch scandal. So this would be a wonderful case study to talk about the ethics of how you conduct your business. So case studies are wonderful for a lot of those outcomes that have to do with attitudes, but particularly ethical issues. And we talked yesterday about giving students a reading assignment or actual problem solving to do before they come to class. So I just now want to just focus a little bit on project-based learning, because that's going to be, for many of you are already doing it, but this is going to be such an important way to get at so many of these outcomes. You'll do it through projects. Okay. Now, when you think about this again, when we talk about a project, and this could be true too if in engineering we tend to build things and to do projects, but this could be if you're a chemical engineer. You don't build a lot of things. If you're actually in biological engineering, they do build, only they're building at the molecular level, so their products are microscopic. But if you're a musician, think of whatever we say about project-based learning is the same principles for performance-based learning. Because in fact, you're going to teach and assess problem, project, process, performance in very similar ways. So what I call here project-based learning is going to apply. So it's student-centered, organized around real-world problems. In other words, it's what do you do in your profession, focused on an authentic skills is very similar with the second one. Okay, it's authentic to your profession, because sometimes it's collaborative, and faculty take on a different role. I'm now a facilitator. Okay? I'm not standing on the stage. For some faculty, this is a hard transition. You have a new role, a new hat, because really, truly, if you think about it, we like being the center of attention. We went into teaching because we like it when people are listening to us. We like being on the stage, and I probably should say, okay? I love having this captive audience, and I can perform, and I can talk, okay? So now you're telling me, get off the stage, get off the center. Your role now is to be sitting somewhere or walking around or sitting with the group. That's your role as a teacher now. And it's a different shift to get used to. So you're now a facilitator and not the deliverer of instruction. Because we like to think that all the information students are going to get is coming out of my mouth. You're getting it from me. When students begin, they're very dependent on you. When they begin their programs. Early in their programs, they are very dependent on you for the information. But you want to get them to a point where they are not. They're self-sufficient as learners. They have learned how to find the information from some place in addition to you, the instructor. Okay? So your role changes from delivering instruction to helping students to find what it is they need to learn. Okay. And the other thing I want to say about Authentic, sometimes we have what we think are wonderful projects, and we have them because, and we do the project because we want to teach teamwork and communication and maybe some design. But the thing that they're building or designing or putting together really is not anything that a systems engineer would do. Let me give you an example. Some part early in the aerospace program, and we do a lot of communications. The students, in one of the very early courses, work together in teams to build these kind of robots out of, must have been steel frames, but they were like big puppets. Okay? It taught design, okay? Taught teamwork, taught communication. Okay? But the problem was, when we talked to students, because part of my job was to talk to students as they were leaving the program, and when we talked about that, it wasn't a real project that aerospace engineers did. So they really did not want to be spending all that time on something that wasn't connected to aerospace engineering. So sometimes we think that we have some projects, but they really engage the students and they look like really interesting projects. The students are very sensitive to having it be authentic, to look like their field. So you need to be careful about some of those. Like games that teach teamwork, but they're not in the context of what engineers do. And I say engineers, but it could be business management or whatever your profession is. All right. So again, if you're going to design project-based learning, from the simple to the complex, and the relevant complexity, figure out what's the context of the experience. And the context here is what professional practice are you setting here? What's the goal? Why do you have that project in there? You need to think about who the target audience. Think of it in terms of, okay, am I planning this experience for third semester students or 10th semester students? Who is this project for? And it's related to the next one. Where does it fit in the curriculum and program? And what is the project's level of complexity? And this is true whether it's engineering or not. And because you want to go from the simple to the complex. So how do you go from the simple to the complex with a project? Okay. Think of it in these ways, in terms of activity, structure, solution, team, and duration. And here's increasing complexity. So when you're putting a project together, okay, when, as an engineer, you do this process, you do it CDIO. But really, what is the hardest part of this process? Is it not the C? Is it not coming up with the ideas to begin with? and the design. Okay? So even though as an engineer, you do it in this process, when you first start teaching it, it is simpler, it is less complex to start with I/O projects. Get them to build. Here's an example. We'll look at some examples. But rather than have them design an airplane, I mean even a model airplane, you know, think about it, conceive it, design, build it, and operate, maybe they take someone else's design and they build it, and they get it to fly.
Excuse me, Doris. We have an interesting example of the activity in programming. Now, we adopt a new methodology that uses first I and O.
Yes.
Older version focus in C and D, and this is difficult for the students.
Oh, because they didn't see the process. So set the context. So if you're going to do an I/O project, you make sure the students know that eventually they're going to put it all together. And by the time you get to the capstone course, they're doing C, D, I, and O, and in this order. Okay? So early on, you say to them, we're doing an I, we're going to build something, and we're going to operate it. You haven't designed it, but eventually, this is the end of the process that you're going to do. And the same thing if somebody's doing just CD. That's fine, we don't have that example, but let's say, you know, this follows with a CD. Or see, this we're following DIO, and then leave the CDIO. But tell them eventually this is what it's going to be.
In our programming course, now the students begins implement small parts of a system. In other version, the student have to conceive, design, and after design.
Yeah, but after they've done the first one. Yes. So increasing complexity. So it increases in complexity both in the kind of activity you do, not both, but in that. And then in the structure. Some of the problems and projects are structured. In other words, you tell the students, here is how you're going to do it. Here's step 1, here's step 2, here's step 3, here's step 4, here's step 5. Okay? Very important to start with those because they're not ready. If it's their first project, you don't want to say, here's the final, what the final project is going to be. Figure out on your own how to get there. Okay? Eventually, they have to do that, but not before they've been through a much more structured situation. So early on, give them structured projects, then lead them into unstructured. Early on, you start with a known solution. Now, it's not necessarily known to the students, but it's known to you. There is a solution to this problem. Students don't know it, but you do. Okay? Before you lead them to, let's investigate this together. I don't know what the answer is. It could be anything. That's too open and unknown and unstructured for beginners.
Last year, I been in a session in construction education, and there was a discussion about where the curriculum pass from structured problems to unstructured. If there was a big discussion about this. There was a limit or a point, third year, fourth year, when the appropriate moment in order to.
Yeah, well, technically I would say when you know that they can do these, move them to these. You know, so it's not a, you know, it depends on your program. How many opportunities that they had to solve structured problems or build, you know, structured projects. And if they've not had a lot, keep them pretty structured till you say, okay, they can do that, and let's move them there. But I don't know that there's the same thing with known and unknown. Same thing with teams for your projects. Start, and you've seen this, okay? Start with individual projects, partners, or a small team, 2 or 3, to a large team. And in some, like in one of our capstone courses, the entire class is a team working on a project. The whole class works on a project, but it's a large team, but they divide into sub-teams. But all coordinated to do this one project. Okay? That's very complex. And in length of time, we talked about that, between days, weeks, and months. We talked about it before, we have that, our experimental course runs 2 semesters. One of our capstone courses runs 2.5 semesters. I'm like, you know what, I'm saying that, I'm questioning myself. I know it starts in the, yeah, 2.5 in a sense, almost 3 semesters, because it starts in their 3rd year, spring of their 3rd year, fall of their 4th year, and it continues about halfway through their final semester. So they might finish the project a little bit early. Some of the capstone courses run 2 semesters.
Was, I think the Project Integrador 1 may be CDIO, and Project Integrator 2 would be CDIO.
Both.
I think both should be CDIO.
No, I think both is very. I think both is very ambitious. In the first project is not.
Well, I mean, the first one we can give them
Design
topics.
is more design,
We can give them
implement,
topics.
operate, and the other is we meet a real problem with conception.
Yeah. And you don't do all the negotiation with clients and getting customer requirements necessarily, because you can assume here are the requirements of a customer and start them in on the design. Whereas at the C stage, they have to actually do the research and find out what the customer requirements are. Yes.
About the size, a large team, is it necessary for more complexity or add more complexity?
It adds complexity. It adds complexity. The larger, if you're working with large teams, you've now increased the complexity of your project. Right. Right. Not that a complex problem needs a large team, but if you introduce a large team. So here are just some examples. Because in the CDIO approach, the guideline is, or the standard in the CDIO approach is, a CDIO program will have 1 or more courses at a basic level, 1 or more courses at an advanced level. So here's some, and when we talk about basic and advanced, it's in terms of complexity. So here's an example. This is an MIT example. They build a little airplane from a kit. There's no C, there's no D. There's I and O. Okay? Because you can't remember, if they can get something up into the air and stay there, that's a big principle. Okay? So it's very structured. They have a kit. We know the solution. It's going to be a plane, and there's a picture on the box. And that's what saves them. An individual, and it doesn't take long. You know, they don't spend a great deal of a semester, a few days, maybe a week. Right? Small project. Okay? Little project. Now, they can sometimes, one of the things that they do is after they build it from the kit, the next time around they keep that same little airplane, but they have to modify it in some way. So maybe it needs to carry a payload, or maybe they need to take off one wing. No. But they have to modify it in some way and still get it to fly. Right? So it's building in complexity.
One example of this is the project that we think with introduction to the engineering. Is just that is
Yep.
the project.
And the thing is, with this, where is this in the curriculum? It's in the first, yeah, yes, first semester in the program. So it's small, but it's early. Get that in early in the program. Here's one from the Naval Academy, and they're building a model rocket from soda straws. So that's maybe more about it. Here they do a little bit of design, still structured, still unknown solution, small team days. Okay? Here's an example of an advanced project, and this one comes from Windshipping from the Applied Physics and Electrical Engineering Department. They're building a robot. So they have to design it and build it and get it to operate. It's structured because, again, there's a limit to the range of solutions to what this robot will look like. And there are certain steps they have to follow. But they still may show some creativity in that they don't all look alike. But there's a limited range to how they're going to differ. Small team, maybe weeks and months. Okay, so what we're doing is, this is not the most complex, okay, but it's still kind of advanced because now we're talking about teams working for weeks and months together. Very advanced. This is from KTH, and this is their capstone course. So they're building, they've done a number of different interesting projects in the capstone course. This little craft that they built goes over the surface of the water, and it submerges, and then it comes back up, and it runs, so it's unstructured. They're just given they figure out what are the requirements. It's unstructured. The instructor does not say, here's how you go about this. It might be an unknown solution because the instructor is in there with them trying to figure out what that solution is going to be. Large team and months. Okay?
Who pays for the project?
Oh, good question.
This is a expensive price for it.
It's very expensive. It's very expensive. At KTH, I don't know. It could be, not a lot. They're not bearing a lot of the cost of it. At MIT, the capstone course is, for the most part, the capstone course is aligned with the instructor's research. So the money that they're working on a project that the instructor is working on for the Department of Defense. They get a lot of money from the Department of Defense. So the money that he gets to do his research, he's really now has a research team, and it pays for the capstone. And it also does this integration for him to say, when I'm doing my research, I'm also teaching. Okay. And the
teacher maybe use this project with test different approach or solution.
Yeah, and it's a continuing, the project, from his perspective, the research project continues year after year. So the challenge there is to find a part of his research project that the students can actually complete in a year. Because you don't want students to walk away and say, whatever's ever going to happen to this. Right? And much of what they were working on, I'm just always so in awe of this, is that they were building little autonomous robots to go on the International Space Station. And that was his project. So each year he develops, a test bed, and they build these prototypes and they test them out. And that part of that project, those little They look like soccer balls. They're about this, just a little bigger than a soccer ball. And there are 3 of them, and they communicate with each other, and they just, amazing. They went to space. They went to the space station. I mean, every project you do is not going to have that kind of magnitude. But to respond to that question, sometimes the department, if it's smaller projects, if the students present a good proposal to the department head, the department will fund, will give them, sometimes it's just a small amount, they might give them $50, $100 to seed money to get started. Okay? But the cost is really not borne by the students, well, except by way of their tuition. Okay? But they don't pay for the materials. And I doubt that they pay for them in Sweden, because in Sweden, for many of them, their entire education is paid for by the government. So, there was another comment?
That's it. What about,
Okay, back.
what about a virtual model?
What about what?
A virtual model.
A virtual model.
Yeah, prototype.
Yes, yes,
Advanced.
yes. Because it may be, it's really, kind of look at these characteristics, and actually you lead me right into the next one.
Okay.
For the projects you have in your course, do you think it's an advanced course, a basic course, or an advanced course, and why? And where does it fit in the overall curriculum? Okay. So what about yours, the virtual model?
Simulation model.
The simulation model? Okay, or let's, so is that in your course, that they build a
Yes.
simulation model? Okay, so what would you say? Is it a CDIO, an IO? Do they conceive,
They like to
design?
conceive.
They conceive it, they
They have
design
to
it?
read to make some research and get an idea of the problem they have. They want to model and then make a conceptual model and then use equations there and simulate and analyze the data and
Okay.
results.
And is it structured, do you tell them step by step what to do?
There's a methodology to do it.
There is a methodology, but they've learned the methodology.
Yes.
So when they get to this, they apply the methodology themselves, okay? Unstructured. Solution, could be any number of solutions.
No. It's not a right solution.
There is a right solution?
No,
there's no right
There's
solution.
no right solution.
Okay, so unknown solution, small team, large team?
3, 4
3, 4, and how long?
semester.
A semester, yeah, definitely an advanced course. What about your game? You said in your first, one of your first courses, you do a game, okay? How would you characterize it?
They don't conceive it. They just design it and implement it, and the operation is just for the teacher. It's not like for the rest of the class, but it's just not the conception. It's just like a prepared exercise from the teacher.
Okay, and team, or each person does it
It's
individually?
individual, yes.
It's individual?
Yes.
How
individual.
long a time?
It's like a month. No. It's 2 weeks. 2 weeks.
It's 2 weeks.
2 weeks at the end of the course.
At the end of the course, yes.
But where is that course in the curriculum?
The third semester.
Perfect. You start, basic course, get them in there, it's structured, there's a solution, short amount of time, a wonderful example of basic and advanced. All right. And to begin with, again, you might say, well, we don't have, if I look across my curriculum, how many projects do students do? And you might say, well, they're not really doing a lot. Don't start by saying, all right, we're going to put projects, one of the project-based learning in 10 different courses. Okay? If you don't have a basic one in your program, put a basic one in early on. And if you don't have a capstone, put a capstone in. And then worry about some of the other projects. So when you're designing that project-based course, you have to make some decisions about teamwork. How many teams will there be? And again, not a formula. It's not a formula that says if you have this kind of a project, divide by 3, find the square root, and find the differential. Smaller teams to begin with before you put them into a large, complex team. But the questions become, how do you form the teams? Do you form them?
Normally self-selection.
Okay. Do you let them choose their own teams?
Yeah.
Okay. What are the benefits of letting them select their own team?
Trust.
Trust, they already know their teammates. Okay.
They also know what the activities in which each of the members of the team are good.
So they tend to give someone who already has the expertise that job.
Yeah.
So think about what your role is and why you're doing teamwork in the class. You need to have, because having them work in teams is one thing, but you also have to make sure that everyone is acquiring the knowledge and skills. So if I self-select on a team, and I end up doing things I already know how to do,
I know that.
you don't learn the other things that someone else has an expertise in.
And besides that, in the real world, you're not always going to work with the people you want. You have to work with the people you have to.
Right. So if you want them to have a more realistic experience, you assign the teams. Now, when you assign them, you can do, in other words, you can randomly select as well and assign them to a team. You sometimes will assign them to make sure that that there is that representation of things that they're good at, and this will happen only in later times when you really get to know the students. But even then, you have to make sure that they rotate roles in the team at some point. So there's not a right or wrong. Another advantage, if they self-select, when something goes wrong in the team and they're not getting along, if you assign them to the team, they're going to turn around and say, you made me work with this person, okay, and it's not working out. I'm not saying that's an excuse, but it's a different thing, because I say, if they've chosen their own teammates and the team falls apart, I just say, you chose them. You chose them, so don't.
And blame me.
Yeah, that's not,
But do you prefer the instructor former teams?
Do I prefer that? It depends on the
As
situation.
you are doing that.
Notice, I think
All
that,
the workshop, in all workshops you are.
Yes, that's right. I form the teams, but I'm actually forming that's a good example, because I did form. Most of the time when I form the teams, I form them randomly. I assigned you to a team, but it was at random. These people or drew a number, except remember this last exercise. I said, we're going to form teams, but I made sure there was somebody from systems engineering in every team. Okay? So there I'm assigning by expertise, and then the rest of you were random. Okay. But yeah.
but if you want to promote the teamwork competency, you can say, you have to ask the students for their abilities, we can say. And for example, in my case, I ask for the students to fill out a questionnaire where they express in what of some activities they feel better. And then I suggest some groups, and they have to validate my decision, and finally they integrate the groups as I say in most of the cases.
But you choose the team,
Yes.
based in this criteria?
They fill out a questionnaire.
University?
Yes, they fill out the questionnaire.
Here is not normal. No? Here there are self-selection teams for all the careers.
No,
I think it's not.
No, before we start the project, they have to fill out this questionnaire where they say
It's good.
if they have been leaders or planning leaders or quality leaders or something like that, and they have to write out the experiences they have had before, and then after I confirm the groups, but they have to be okay with those groups, because in this context sometimes the students they have been some kind of troubles and something like that. Yeah.
Eso no es normal, lo que hace Hugo no es normal aquí en la universidad. Incluso en la maestría los estudiantes pegan en los grupos y no dejan quitar de los grupos. Y yo creo que debe ser lo que dice Doris es cierto. Pueden ser algunas cosas, pueden ser autoescogidas, pero otros para fortalecer una competencia mucho más diversa, sobre todo que estamos comprometidos con la formación de todos, no sobre un grupo que quiera sacar 5 y que tiene 3 muy buenos, sino con todo el mundo. Entonces, digamos, es obligado a mezclar.
Pero
ellos no pueden
pero la mezcla no debe ser...
No es random, no quiere decir que es random, es lo que es de Doris. Y algunas veces usa random, otras veces dice, dependiendo de las competencias, quién es de ingeniería del sistema aquí, usted una carta, listo.
The last semester, what we did in this course is that we had 3 groups, and then we conformed just one group, and they decided now the new roles inside the group. They say, okay, the roles we use when we start the project, those are good, but now we feel we need, for example, they say we need a communication leader role. And then one of those students was the leader for communication, only for communication, and they establish a new structure, you see?
And again, it depends where it is in the curriculum, okay? Because one of the problems early on, if you let them choose their own groups, what happens, and I'm sure you have students that nobody wants them in their group. That student, for whatever reason, and some students don't want to work in a group, they want to work by themselves. And if you give them that option, you're defeating the purpose of teaching teamwork. And for the student that nobody wants to work with, that student has to learn teamwork. Okay? So I would tend to form the teams, assign the teams, whether I do it randomly. And at the beginning I would do it randomly because I don't know a lot about the students. But I would make sure that, you know, that person that nobody wants to sit next to, for whatever reason, gets on a team. But the thing is, remember, these teams last a week or 2. You know, they're not married to this team for life. So you don't want them to say, okay, you're the team, and for the rest of the semester, this is the team you're going to work with. You know, that is not going to help you. You need to mix up the teams. Next time you do some kind of project, you've got a different team working together. But now when you get to a capstone, and in ours, which is the large team broken into sub-teams, the instructor usually asks at the beginning of that capstone, what is their preference for the sub-team they want to work on? Okay? And they give 2 choices, because there are usually about 6 different sub-teams. And they choose, you know, their first choice and second choice. And for the most part, the instructor is able to put them on a team that they want. And so again, here's a question that they are really practicing the skill that they're already pretty good at, but that's their contribution to the team. And that's a very real situation in the workplace. You get on a functional team because you bring something to the team that others are not. So that's a real situation. And they've had several other opportunities to learn teamwork skills and to learn the content. So the criteria that you use, you want to be very careful about ability levels, gender, culture, language. Now, do you have sometimes you have to say, if you're in an engineering program where there were very few women, okay, we feel, well, I want to put one person, one woman on every team to kind of spread them out. Well, what are you doing for that one person on the team? Now you have one female student and 5 male students. Okay? I mean, it's spread when you look across the table. Okay, each team has a woman. Okay? But that woman is outnumbered all the time. So even if you put 2 women on the team, and some teams don't have any women, it's better for those female students. Okay? And not because they're necessarily going to get along better with the female student than with the male students, but there's still that, not that feeling of being absolutely outnumbered. Okay? And you're not sensitive to that unless you've been the sole person that's different by culture, that's different by major, that's different by gender. That sort of thing. Now, you have a good representation of both genders, you don't have to go through that. Well, I have to make sure that, what if I have some teams that are all women? What if I have some teams that are all men? As long as, again, they're not married to the team for life. So when they get to the capstone, it's probably going to feel that way. But even in the capstone, within the sub-teams, they need to change their roles. Okay. Communication, the same thing. You need to decide.
But when you say the different sub-teams, you said like a leader for every sub-team, and they choose where they want to be, or?
That I would probably let them decide. I would say to them, okay, every team has to have a leader, every team has to have the person who's doing the documentation, every team has to have, you choose amongst yourselves. Okay. And if it's a long-term team, like for a whole semester, at some point in the semester I'd say, all right, now you need to choose someone else from your team. I might not change the team, but I'd say, okay, you've been the leader for a while. Someone else in the group has to be the leader. Someone else has to be the recorder. Okay, so I'd change the roles. And again, if leadership is one of the learning outcomes of the course, then every student has to have an opportunity to be the leader.
It's convenient to create one outcomes for course or one outcomes for team.
Both, because I would say if you've got sub-teams, might you have different disciplinary outcomes, the learning part different for different teams? Now, I would still stay with the learning outcomes for the course and just leave this idea of the project-based learning as the opportunity for them to get to the outcomes of the course.
Or created like Pitacora?
Create?
Like Pitacora for team?
I don't know, but maybe. I'm not sure how that would work. But you want to think of the project as the way that the students see that the project is not the end. Okay, it's not the focus, it's the means for students to develop the learning outcomes. So when you're designing a capstone course, really the learning outcomes from semester to semester to semester, and year to year to year, the learning outcomes will stay the same. The project might change. But the project exists as a teaching method so that students can get to the learning outcomes. The learning outcomes for the course.
Observation.
Yes.
Para los industriales, el laboratorio de manufactura flexible no es el objetivo. El objetivo es ver qué vamos a hacer con el laboratorio flexible.
Everybody gets right.
As we are building a new lab of flexible manufacturing system for industrial engineering. The big question is, what can we do with this lab? Really, this is the main point. The objective is not to have itself. The objective is what can use this gap for improve some competence or for improve some skills for the student.
Exactly, exactly, okay. And we've already talked a little bit about when you're thinking about this now, you need to think about the learning environment. Okay? You don't usually have to worry about this if you have a lecture-based course. Unless you're going to be doing concept questions and you want to use the electronic response systems. Then you have to worry about the setup of the facilities. Does your classroom allow you to do that? But if you're working in a laboratory, a project-based learning, the learning environment, the resources and materials and equipment becomes very important. This is at Universidad Católica de la Santísima Concepción prior to this terrible earthquake. So I have no idea what this poor building looks like now. They really suffered much damage.
Show the Polytechnic of Montreal working space. You have
The Polytechnic of Montreal, or the one from Queens, Canada, in
Where?
Kingston. Not in the slides.
But it's wonderful workspace and integrated. It's a building. It's a building for engineering.
They did the same in Liverpool, in the UK. Built, I do have that, but not in the slides. All right, just one or two points that I want to make. And the idea is, see, again, the idea is you don't have a better course because you use a lot of different teaching methods. Okay. The idea is think about a variety of methods across the curriculum so that in a single course, maybe you don't have a lot of different strategies, but if you look across the student's experience, they're coming up again, they're learning using different strategies. But even yourself, think about using a variety of methods. And this this diagram is really an adaptation from David Kolb in 1984 published a book called Experiential Learning. I think the book is out of print now. And David Kolb's part was what you see in the rectangles here. And the rest of the words are the adaptation by the CDIO. But the question is, okay, so abstract generalization, examples of that would be lectures that teach concepts and models and laws and principles. And active experimentation, tutorials, activities, labs, and simulations. Concrete experience, design, build, or field, sending them out to, depending on your profession, you might not be building things, but the concrete experience is what's going on in their field. Teacher education is a good example. And then reflective observation, thinking about what we did. Now, in traditional higher education, and even in traditional engineering, traditional professional practice, where do the programs start? What is the student's first experience? What do we do with them? Where do you start them on that circle?
Abstract.
Yeah. Don't you do this? Put them in lectures. You teach them the basic principles of mathematics, you teach them the basic physics, you teach them all the principles of aerodynamics, all of the theory and principles, everything abstract. Then what do? You say, okay, let's have a little tutorial about this. Let's do an activity. Let's do an application of what you've just learned. All right. Now let's take that and let's build something. And now let's think about what we built. And we do some journals and portfolios. What the CDIO project approach is trying to say is that's fine, okay, but don't always start there. Particularly because I remember talking about this part, students come to you without a lot of background, and we make them, we give them all those theories, and by the time we finish with them, they don't want to be engineers anymore because they haven't had a chance. So sometimes Start here. Give them a common experience. Have them build a simple thing, which you're doing, okay? So you start the cycle here. The same thing if you are teacher education or the other program I'm working in now in pastoral ministry. I mean, we don't build projects in there, but our profession is working with people in churches, okay? Well, how did my program start? Here. Okay? And in fact, it doesn't get to there till the very end. You know, it's a little bit late for me. So we have no common experience to talk about because we don't know what it looks like. So sometimes start here. So what you're saying is, okay, I've been out in the field, I'm in teacher education, I go out to the field and I observe and I practice with one student on one lesson. I haven't planned the lesson, I just do some tutoring, but I've got some experience in the field. Now I come back and think about what happened. I reflect on the experience I've just had. Now, as an instructor, I can draw out from you, here are the principles. Here's why this has happened. Here's why you couldn't get it to work. Here's the principle you needed to know. But they have a reason for wanting to know this principle. And then you get them to say, okay, you've learned the principle from this concrete experience. Can you apply it in a new situation? So now let's experiment in other situations, but you've seen a concrete example. Again, does every learning experience begin that way? No. But until students have a common experience base, it's hard to get here. So think about, sometimes we do this. And actually the reason why we put concrete experiences.
Probably it has to do with the pertinence that's what the student.
The relevance, the pertinence, yes.
It's more likely you engage students with something that's pertinent for them.
Because now they want to know. They have a reason for wanting to know that
It's
principle.
important, and then you can go the rest of the way.
Absolutely, absolutely. Even the mathematics and the physics that, theoretically might be more difficult to connect, but still saying, okay, this would have, your observations here, or this first design experience would have been more successful for you if you had known these mathematical principles. If you'd been able to figure out the equations that would lead to it. Yeah. We're not going to, we'll start a little bit of discussion of this tomorrow afternoon, and then there's just a little check one. We'll do this tomorrow too, just kind of where are we tomorrow. But the bulk of what we're going to do tomorrow is the learning assessment. We're really going to focus on that and do some, and design some learning tools. That's tomorrow afternoon. A las dos, we'll have it. Thank you very